All right, 4-1, day 2. There's not a lot here. We got most of it out of the way yesterday. But I'm not going to rush since it's a short chapter anyway. But 4-1, day 2.
We can take our time.
Yes. We are going to do mean, variance, and standard deviation. And standard deviation of a probability distribution, that's that table, using lists on the calculator. I'm going to call the using lists by hand, because then we're going to do it with one of our stats after that. All the way through this whole semester, we're going to be doing things by hand, which still uses a calculator, but it's a little more steps are involved in it. And then I'll say by program. And we'll do it on and off all the way through the whole semester, and you have to know both ways. And the reason I do that is, if you ever have to take stats again, you might have some ancient professor that wants it done by hand, or you'll have a newbie that's all technology. And I don't know which street to go down, so I just go down both streets, and then you know everything. So that's how I'm going to run the whole rest of the semester. So here we go. So we're going to do it by hand first, which is using the lists on the calculator. Okay, so the first one we're going to do is the mean. Mean. And these are population values. You remember the symbol for population mean? It was on your last test. Most of you remembered it. Some of you did not have it written down. It's a little mu. The formula for the mean of a probability distribution. What does that mean we're going to be doing? Adding up, that's the sum, of each x value multiplied by its probability. So you're going to kind of learn what the formulas are saying too. So this says take each x, multiply by its probability, and then add all of those together.
What's the x over? What's the line over?
That's sample mean. It's still a mean, but it's sample mean.
Is that on the test, like...
As far as what?
Was there a question, like, what is the population mean, and what is the sum mean symbol?
The last question asked for all the different symbols.
Okay.
Okay, so we are going to do this with lists. And we're going to use that same table we started, and we're going to add to this table too. It was the number of sales made. And then we found the probabilities yesterday, so we're just going to write them down. The probabilities. And they made from 0, 1, 2, 3, 4, 5, 6, 7 sales. So I'm just copying this as information from yesterday. And then the probabilities were 0.16, 0.19, 0.15, 0.21, 0.10, 0.08, and 0.02. All right, so the first thing we're going to have to do if we're going to use lists is put our sales in list 1, put our probabilities in list 2. So after you get that written down, I'll wait for you to type those in.
We have to do L1 times
Mm-hmm.
L2 and then the sum of all.
Mm-hmm.
Okay.
Nice, Michaela. Okay, so we're ready to make the calculator follow this formula. So what we've got is take each x value and multiply by the probability. So my x values are in list 1, my probabilities are in list 2, so you're going to want to go to L3 and tell it to do what? If I wanted to multiply x by p of x. List 1 times list 2. Now, I am not going to make you write down all of these, because that's just painful. All I want you to do, I'll show you the shortcut we're going to have for these. So I'm up on L3, remember you're going to be up at the top. Say take everything in L1, multiply it by everything in L2, and if I hit enter, it'll do that. I only want you to fill in the first one and the last one. If you get the first and last right, I know you've got everything in the middle correct. Are we in agreement there? Just to save some time.
0.14.
Oh, thank you. 0.14. Okay. So now that I've gotten the calculator to multiply these together, how do I get it to add them up? Go into list and take the sum of what? List 3. So I'll quit. Go to, remember where list is above the stat key? Go over to math. Sum of L3. 2.6. So 2.6 is the average number of sales per day. There's one answer. We have followed that formula. We multiplied and then we added. That was by hand. Okay, ready for, because we're going to add, the formula, the by hand formula for variance. Which is your sigma squared, says you're going to add up, take each x value, subtract the mean, take each of those differences and square them, and then multiply that answer by its probability. And we can do this all in one list.
So you couldn't do it before you find it?
No, you'd have to find the mean first. So, with the formula, we're going to get, in list 4, we're going to make it do all of this, and then we'll sum up list 4. So let's see how we can get the calculator to do this. So L4. I'm going to use parentheses just like I've got here. Where are my x values at? I want to be able to see both here. Okay, there. Where are my x values at? L1. This is L1 here. So take L1, subtract, what should I tell it to subtract? 2.6 for this problem. Now what? Close the parenthesis. What do I want it to do after it does the subtractions? Square it. And then, how do I get it to multiply by the probabilities? Times L2. So that's exactly what we're going to type into L4.
Okay, what is variance again?
Variance tells you, it's an indication of how spread out the data is. It's the average distance away squared, which is why we do standard deviation, take the square root. So we'll go into Stat or Edit. I'm going to go over to L4 and clear it out. Now I'm going to go back up. Use your parentheses. Take L1, subtract 2.6, square that, multiply by L2. Enter. So again, all I want is the first number, 1.0816, and the last number, Oh, let me see what you typed in. Hit go to. Oh, you used a little bracket instead of a parenthesis.
Oh, well, okay.
There you go. If you hit the go to, like she got an error, number 1 says quit and number 2 says go to. If you hit the go to, it goes to the spot where you type something it doesn't get. That's how I could find it quickly. Okay, now what? Now how do I actually get the variance?
Take square root.
Nope. What haven't I done yet in this formula? The sum. I haven't done the sum yet. So now we want to sum L4. That will be our variance. So I'll quit. Sum L4. And that would be, if I put units on this, that would be sales per day squared, which actually has no meaning. But maybe we should write it down. Sales per day squared.
What was
This would be sales per day. And then, what's the relationship between variance and standard deviation? If standard deviation is just sigma, how do I get it? It's the square root of the variance. So I don't need any lists anymore. All I've got to do is take the square root of the answer that I just got. And I should label this so we know what we've got. This is sigma squared. So if I do the square root of 3.72, I get about 1.93. Now we're back to sales per day. That's the average distance from the mean. So there's the 3 answers. That's what I call by hand.
by calculation?
By program is coming next.
Shorter.
Much shorter.
Are we gonna test it on both? Or-
Both, yep. It'll say by hand, by program. Good? Not yet. Michaela, pick up the pace. You're not going to make it in life.
We are allowed a note card on this.
Yes. Definitely going to want to have your formulas down. All right, so then mean, variance, and standard deviation by calculator program. Mean, variance of the program. You still have to use the list. You enter the X values into list 1, which we've already got done. Enter the probabilities into list 2. Which we've already got done. One var stats has so much useful information in it. But to tell it, basically it's a weighted list because of the probabilities. To look at both lists, you have to type it in, L1, comma, L2. And then on that screen of all that information, we're going to find the mean and the standard deviation, and then we have to figure out the variance on our own. So, we've already got the data in here.
Is that number 3, or did you just put it there?
Well, I guess I could call that 3. Sure. That works. So, try it. Stat. Over to calc. L1, comma L2. The mean. Where do I get the mean on here?
first one.
It is the X bar, because the formula's not different. The calculator doesn't know whether you've got a population or a sample, but most times statisticians are using samples, so they went with the most common form of the mean, which is X bar, but you just got to know that X bar is going to be the same as the population mean, 2.6. You can look all you want for sigma squared on there, you're not going to find it. What are you going to find?
1.28.
Just the sigma for the standard deviation. So the standard deviation is the 1.929 if I want, or 1.9. What did we get? What did we write down? Go 9.3. And then how do I get the variance? You got to square that. So is 1 var stats a lot quicker? Yeah.
What is 2 var stats?
We don't get into that. I couldn't tell you.
You don't know.
I don't know.
Oh.
Well, I'm going to say it's 2 variables, an X variable and a Y variable. It's paired data, but I've never dealt with it, so it's the only thing it can be, really, now that I think about it. Okay.
We done?
Nope. I've got 2 things left.
Are they examples?
Yep. Just examples. Well, actually, there's a definition in there, too. We aren't going to be done that quick, for goodness sake. Okay. Example 2.
Can we have one space?
Is number 26, which you already started.
This is the last space?
It's a table, yes. I want you to find the mean, variance, and standard deviation, and then answer some probability questions after that. And find the probability of having at least 3 accidents and then find the probability of no more than 2 accidents. And what was this looking at? Younger drivers or something? 4-1. The number of motor vehicle accidents per student in a recent year at college. Oh, these were college students. Okay, and you did number 26. It was the number of accidents and then we'll just copy down the probabilities because you already did that. So it was 0 through 5. And then the probabilities were I better make sure because I did them myself. I'll go to the back of the book to make sure I got them right. A79. 0.152, 292, 249, 178, 102, and 026. Okay, so go ahead, type in your list. We'll do this one by hand to practice, because obviously the by hand is a little bit more complicated understanding the formulas. So we'll find the mean, the variance, and standard deviation. Ah, dang it. Clear. Clear.
What happens if I accidentally just got rid of my list one?
If you got rid of your list 1, because you hit delete instead of clear, you're going to go to stat, down to number 5, set up editor, and then hit enter twice till it says done, and it'll bring it back. Yeah, if you hit delete when you're up at the top, it'll wipe the whole list out. Throw it into nowhere land.
You should work at tech support for Texas entry.
Yeah. Run some workshops. Okay. 0.152.
How much do you get paid for stuff like that?
I don't know.
Google it.
That's funny. 'cause you
Okay.
can Google the answer.
So our goal is to find the mean first. If you need to look back at the formula, what am I going to, this is L1, this is L2, what am I going to tell L3 to do?
You're gonna tell it to, times L1 and L2.
Times L1 and L2 together. So I'll quit. Oh no, I'm not going to quit. I'm going to go up to the top. L1 times L2, obviously 0 here. And at the bottom, 0.13. And then to get the mean, what are we going to do? What else is in the formula that we didn't do yet?
Add 'em.
The sum of them. So we're going to sum up L3. If you need to write that down, write it down. But I'm not going to write it down. Sum up L3. 1.862. Next thing we're going to find is the variance. And we're going to use list 4 to do that. Now you got to look back at your formula. What did the formula say to do?
L1 minus 1.862. What was the parentheses? Square root of 2.
He's remembering it.
Times L2.
Yeah.
Yep, there it is. So we needed to subtract, square, and multiply by the probability. So L in parentheses, L1, subtract 1.862, square that, times by L2. And I'm in L4. Let's see, L1 squared times L2. I got 0.527. And on the bottom, 0.256. So far, so good? Then if you sum those up, that will be your variance. So I'm going to quit.
Do you want this round to do a ball?
Sure. And then all we need is our standard deviation, which is just square root of that. That was just review of the by hand way, just to make sure everybody's good with that. But I do want to answer those 2 probability questions that I asked. And we already have the individual probabilities here. So my first question was, what's the probability that a student has at least 3 accidents? What does it mean to have at least 3 on this table? 3 or more. So what's the probability that they have 3 accidents, or 4, or 5? What do you think we have to do here to figure that out? Add those 3 together. So we're going to add these 3 probabilities. 0.178 plus 0.102 plus 0.026. 5 accidents per student, that's a lot. I think I'd take the driver's license away. Exactly.
What makes you really happy when that happens is that the next day how we're doing I'll take that, Erica, you are clever.
Clever. Okay, what does it mean to have no more than 2 accidents? What does that mean to you? No more than 2.
0, 1, or 2.
0, 1, or 2. 0, 1, or 2. So we're going to add those 3 probabilities together.
Did we need it? I need it.
No, I just wanted to practice that again. No, I did just want to go through that again one more time. No, you didn't need those to answer those 2 questions at all. Okay, last thing I have for you is a definition with a quick example, which we're going to use one-bar stats for. All right. All right, the expected value
Talking like a couple lines here.
Well, this is all I'm going to write for this. The expected value is equal to the mean.
Wait, it is the mean? or-
It is the mean. It is equal to the mean. It is equivalent to the mean.
But it's not the mean.
No. Very, very good distinction.
But,
Well,
so which one should we put? You're saying that that is the mean.
yep. So the problem will ask for give the mean, the variance, the standard deviation, and the expected value. So you're going to give the mean. Well, when it comes to expected value, you're just going to write down the same answer you had for the mean. So why talk about expected value? Exactly. I didn't get it on the start because my stats background is very limited. But my daughter's into a stats career, and they use this expected value in much higher level statistics all the time. So, I mean, it is used,
There's
but
a career in statistics.
yes, very, very lucrative career in statistics.
What does that mean?
Lots of money.
Oh.
Yeah.
I think I'm just gonna bank on being an athlete.
So when you're all old and everything, you're gonna be like, yo, daughter.
Yeah, exactly. Remember when I put you through college? Yeah. Okay. There's a raffle that's going to sell 1,500 tickets.
But I bet you can still do calc credit on that.
At $2 each. There are 4 prizes. A $500 winner, $250 winner, $150, and $75. You're going to buy 1 ticket. You are going to find the expected net gain to you. So if I buy 1 ticket, what do I expect to get in return? Well, we'll see. So, what we're going to do is make a probability distribution and find the mean of it. The mean of this probability distribution will be what I expect to get every time I buy a ticket. So, X is going to be my net gain. What do I mean by net gain? How much I gain, my money over what I've spent. So X is going to be the net gain. And then you're going to tell me the probability of each one of these net gains.
Are we gonna write anything about that?
Nope, it's just a horizontal table instead of a vertical one. What? Well, we're going to find out in a minute. Not too many. How many things can happen to me if I buy a raffle ticket? How many outcomes are there going to be, possible outcomes?
5
5
total.
total. So there's going to be 5 total. So what could happen? What's one thing that could happen with my ticket?
You win none, no money.
No, I win none of these. What's my net gain then if I win none of those? Negative what? Negative $2 is my gain. Negative $2. What's the probability of me not winning? How many tickets are not winners? Yeah, 4 of these are winners. The rest of them are losers. So there's 1,496 losing tickets out of the 1,500. That's the probability that I lose my $2. Okay, that's one thing that can happen to me, more than likely. What's another thing that can happen to me? What could I win?
$75.
What's my net gain if they give me $75?
$73.
$73 is my net gain above what I put in. So it's a $73 net gain. What's the probability of that happening?
Would you just do a range?
140,
How many tickets are going to win $75? 1 out of the 1,500. What else can happen to me?
250. Or wait, let's do 150.
Let's do the 150. What's my net gain? 148. And there's 1 winning ticket there.
Wouldn't you just do a range for that though?
Well, I don't know what you mean by a range.
Like just 73, like dash through 498. Just it'd be 1 over 1,500 or 4 over 1,500.
Because each one of these has a different net gain though. That's why. So the 250 would be a net gain of, oh no, I did that one. Oh no, I didn't. 248, 1 winner there. And then the last one is a net gain of 498, and I have a 1 winner there. Notice the probabilities will add up to 1, so it's a probability distribution. So now, we're not going to do it the long way. All I need to get the expected net gain is find the mean. So the expected net gain is the mean. We're going to use 1-var stats here. So we only need the 2 lists. So -2. And the probabilities, you can type them in as fractions and the calculator will kick them into decimals, but that's okay. Then quit and run your 1-var stats L1, comma, L2. Don't forget to tell it to look at both lists. So what do I expect to gain every time I buy a ticket?
Negative $1.35.
Negative $1.35.
In other words, don't do it.
In other words, don't do it. All of your casino games out at the, obviously at the casino, all have negative expected values, just so you know. If they didn't, they wouldn't stay in business. Okay, that's all I have for you.
Unless you run another one, you know.
Of course, I didn't write the assignment down.
I bought a scratch off one time. I lost $2 and never looked back.
That's illegal, you're not 18, I'm
My
telling
dad got it
you.
informed.
Let's
My dad
see.
got it informed.
I'm telling the cops.
Do it.
161.
Say now, do ya? It's not even scared. That's what I thought. Yeah.
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 Dad.
Huh?
Tell Katie's dad.
3,
Mr. Belushi loves you.
24,
Yeah.
Yeah,
He also loves the law.
25.
I love you.
Still look.
27 to 34.
You're illegal.
I'm not, I personally
Okay.
am not illegal.
Yeah.
This chunk is going to be 1 var stats.
The other part's by hand.
And the other part's by hand.
Shoot.
Chinky.
So 3 by hand to practice, and then the 1 var stats there.
Can I get an odds or evens on the 1 bar stats? Going
All what? 27, 28,
no,
29, 30.
I said odds or even.
Oh. What?